Before we start, I wanted to acknowledge that the National Alliance for Partnerships and Equity have contributed to sponsor this chat, as well as IEEE's Solid-State Circuits Society are also sponsors of today's program. So thank you for joining the chat. My name is Wanda Gass. I will be talking about closing the gender gap today, and I'd like to start to give you a little background about myself before we start on the topic. My Bachelor's of Science degree was from Rice University in electrical engineering, and then I got my Master's of Science at Duke University in a specialization in biomedical engineering. And I joined Texas Instruments straight out of school in 1980, and my first job at Texas Instruments was to the development of the first digital signal processor that was created, and I was one of the co-authors on some groundbreaking patents that came out of that early work. I was involved in research and development at Texas Instruments for 31 years. During that time, I was elected to TI Fellow in 1999 for VLSI, Design and Architecture Design and Signal Processing. I became active in IEEE in the mid-1980s, first in the Signal Processing Society, and later on in the late 90s in the Solid-State Circuits Society. I have been involved in several technical committees and have been involved on the program committee for ISSCC, International Solid-State Circuits Society conference, on that program committee, and was program chair of that conference in 2011. I was elected to be a senior member of IEEE in 2001 and was elevated to IEEE Fellow in 2007. I began my work with women in engineering in the early 2000s with IEEE when a group was formed here in Dallas. And then I was asked in 2011 to be the liaison between the Solid-State Circuits Society and women in engineering. So I took on that role about a year and a half ago. We in Solid-State Circuits Society has held a networking event for women at their flagship conference, ISSCC, for about the past 10 years, where we've invited women to gather together and hear a speaker for that event. And the Solid-State Circuits Society has helped in sponsoring the physics camp, and they made a special effort this year when they were recruiting graduate students to join their local chapters to make sure that the participation of female and male students was 50%. So I'm really proud of the work that Solid-State Circuits Society has done to increase and encourage the participation in women. My journey on closing the gender gap started pretty early at Texas Instruments, where there was some early affinity groups for women that were created in the late 80s. We call those Women Initiatives Network, and it's called WIN for short. And those were started as support groups for women at Texas Instruments. In about the year 2001, a group of senior leader female VPs got together and created a group of a collaborative fund. We decided to pool our money together and start a fund that we decided would go toward encouraging high school girls to be prepared and interested in careers in engineering. So that work actually started in 2001. We felt that the effort is there in a lot of places for girls in middle school, but girls in high school is another place where females tend to drop out of the career path for engineering. And so we decided to focus on programs in that area. It's interesting to note that women that want to go into medical career or become an attorney and get a law degree, they make those decisions after they've been at college. But for engineering, that critical decision is really at the end of high school. And so we felt that preparing girls in that time frame was a critical step in keeping them from dropping out of the pipeline. So if there's any questions along the way that you would like to see answered during my presentation, just feel free to type it into the box there next to the video, and I will be glad to answer questions as we go along. So I'm going to get started on kind of our journey and closing the gender gap. We started out with 10 women at the beginning that had pledged their own money to start the collaborative fund, and we decided to look for programs that we could grant to that would support high school girls in the area of science, technology, engineering, and math. And there really weren't any programs available at that time, so we took the initiative to start 3 programs that we felt would be aimed in the right direction. Before we did that, we actually looked at the one of the key requirements to going on in a technical degree in college is having advanced placement exposure to some of the more stringent sciences, specifically chemistry and physics. And when we looked at the data here in Dallas, we found that physics was actually where the biggest gap was between the boys and the girls that were taking the exam. So that's kind of how we decided to focus in on our programs. So we created 3 different programs. The first program was a physics camp just for girls. And the second program we started was a teacher professional development for teachers, where we taught them about gender equity. And the third program that we started was teaching guidance counselors about how to know more about engineering and technology careers and how important it was for women and females to be an important part of those options, and that they should be encouraged to pursue those while they're in high school so that they're prepared when they graduate to go on to get a degree in college. So we started out the programs in the Dallas School District, and the camps started in 2003, as well as the teacher training. The professional development for teachers is actually a 24-hour class that we give to teachers throughout their development and throughout a school year. And so we start off and kick off the sessions with some information and give them some homework assignments, and they go and apply those back in their classrooms. They come back and have another 3-hour session, learn more information, and go back and apply it to the classroom. So those kinds of interactions between the teachers teaching in class and learning from the instructors about gender equity happen throughout the school year. So it's actually a full 24-hour class at the end that they are exposed to the concepts that help them. What's taught to the teachers is to learn about social learning theories, which includes growth mindset, stereotype threat, attribution theory, and those are explained to them that through techniques that the teachers can do in the classroom, they can kind of counteract some of the social messages that students have been exposed to their entire life, which has a tendency to bias people toward thinking that males are much better at math and science than females. Actually, Genetically, that's not exactly the case, but society has programmed us to believe that that is actually a truth. And so the techniques that we teach teachers help them understand what they can do to kind of undo those messages that people have heard for so many years, and how they can, through micro messages of affirmation, help the girls have the growth mindset and the persistence to continue to work at the subjects that may actually be difficult for them to understand or handle at the beginning, but their persistence and attitude can actually carry them through to be great learners and great performers at the end of the day. So the second thing that we did was we also created workshops for counselors, and these covered STEM careers. The STEM careers include science, technology, engineering, and math, where some teaching the counselors why it was important for the female students to be interested in that and persist in those topics, and why it was important for them to go on in college to major on those things, and that they would get positive reinforcement from the counselors when they were creating their 4-year plan for high school, as well as what college majors they might pursue in their senior year. So understanding more about what engineers do, what engineers look like, what motivates people to go into engineering, gives the counselors a set of tools that they can use to encourage the females in this direction. And so this workshop is actually a half-day workshop that is offered to the guidance counselors. We've actually done the workshop not only for high school counselors, but for middle school counselors and elementary school counselors throughout the school district, also in Plano as well as in Dallas. So those are the 3 programs that we've piloted. Those were deployed by different nonprofits over about a 10-year period until about 2 years ago. We created a partnership with the National Alliance for Partnerships and Equity, and they took over the deployment of our program to
Call from name not found.
So the programs were taken over by the National Alliance for Partnerships and Equity, and those were they were able to deploy the programs not only in Dallas and in Plano areas as we had already done in the past, but they were able to expand the programs to other school districts in the Dallas and Fort Worth area. So through their efforts, we've been able to have actually 12 years of programs for the physics camps. And we have some really interesting data that we would like to share with you about the teacher training and the physics camps. So the physics camps are a 2-week program that is offered to girls that have completed their sophomore year, and they are about to go into their junior year taking pre-AP physics. And we look for girls who have completed Algebra 2 in high school before going on to take their pre-AP physics. And the girls that have met those prerequisites for math and are signed up for pre-AP physics are invited to come to the camps. We, through funding jointly with Texas Instruments Foundation and TI, we were able to support the camps for free in the Dallas area. We know that there is a high percentage of students across the district that are in need of financial support, so we provide transportation through the public transportation in Dallas so that they can get to camp and they don't have to provide their own transportation. We provide them with a TI graphing calculator as part of coming to camp so that they can go on and use that tool in school after they've finished camp, which is actually something they may not be able to afford if it wasn't provided through the camp. And we expose them to subjects not only about physics, but we teach them about math and we teach them about spatial skills. Another important component of the camps is to help the girls see role models of women that are professionals in the field so that they can understand and ask questions about what it's like to be in those jobs. Another advantage that we offer this girls that come to the physics camps is a chance to come to a local corporation and see what it's like to live, to work in a corporate environment and visit some of the programs that are going on in those corporations. So the girls get a chance to interact with some of the younger women who are either in a co-op position and still in college or have recently hired in to Texas to the company shortly after graduating from college. And the other things that we do are we offer them hand-on exposure to information that to topics that they've not been exposed to. We introduce electricity, we introduce velocity and trajectories and optics and several things in the kinematics area. One of the best things about the camp is we have wake-up activities in the morning when they first get to camp, and those wake-up activities really engage them in learning through watching and seeing visually and hands-on activities that give them the concepts before they're actually asked to do some of the lab work. And this actually is a fun way to engage them and teach them concepts that they wouldn't otherwise know. So the labs are presented in a way that they have to think through and do problem solving and come up with the answers themselves. So it's kind of an inquiry-based approach. And the labs themselves obviously are hands-on, but very interactive and collaborative in their work. We feel that the girls that have attended the camps go into their first physics class with a much better attitude about persisting in the coursework, even if it's hard, and learning it so that they can be successful in that first year of physics so that they would actually go on and take a second year of physics while they're still in high school. Because we believe that that's the gateway to getting them into a successful engineering program in college. So we have data that shows that girls are more likely to take and pass the AP Physics exam if they've actually gone to the camp before they take their first year of physics. And they are passing the exams at 18% percentage points higher than the girls that didn't go to camp, and they are actually have closed the gap between the girls' performance and the boys' performance across the district because of the camp's experience. We've seen that the teacher training that we've done has caused the number of girls taking both AP Chemistry and AP Physics to go up significantly after the teacher training, and that the boys and girls of those teachers are scoring higher on their end of course exam at the end of each semester because of the teacher training. So we've seen great results when these three programs are offered together. We've actually done a longitudinal study of the girls that in Dallas that attended the camp. We took a cohort of girls that graduated in 2006, and we we followed them after high school, and we grouped them into the girls that had gone to the camps and the girls that hadn't. It was a demographically similar control group, and we found out how many went to college, whether they completed a 2-year degree or a 4-year degree, and if they completed college and what that degree was in once they completed college. We found that the girls that had participated in the camp had 93% had enrolled in college as compared to only 77% of the control group. And we found that 66% of the girls that had attended camp had completed a 4-year degree in college within 6 years, and that only 24% of the girls had completed college in the control group. And then when we looked at the data from all the students that had completed a 4-year degree, both in the control group and had gone to camp, that the girls from camp were 2.5 times more likely to get some kind of degree in science, technology, engineering, or math, and that they were 5 times more likely to have earned a degree in engineering. So that another thing that we have done with the physics camps is we have applied for and received the ability to be included in Change the Equation STEMworks database. This is a rigorous evaluation process where the camps have been evaluated against a strong criteria to see if they qualify to be included in the STEM database. This is a database that is used by over 110 corporations across the United States that are looking for programs in STEM that have actually made a difference. The teacher training covers several different areas. The teacher training covers not only social learning theories, it talks about what people do that cause implicit, that might result because of an unconscious bias in the classroom. We talk about the kinds of messages that teachers can give to both the boys and the girls of all racial ethnicities to help them realize and achieve their full potential, so that nobody is overlooked or labeled in a certain way that their performance might be less than what they're actually capable of. So we teach the teachers how to make sure that when they ask a question, not only do they look and call on kids equally across their classroom, that they actually wait for a few minutes or a few seconds after they've asked the question and don't necessarily call on the first person that raises their hand. And we also found that arranging the lab groups early on in the beginning of the school year so that the girls might work with the girls and the boys work with the boys, so that they can actually try on all the different roles that are available in the lab group. It lets the girls have more hands-on exposure to the lab equipment, and it also allows the boys to maybe have to do some of the note-taking and recording of the data and analysis of the experiment. And other things that we found that work great in the classrooms is that we allow the teachers to think about how to do follow-up questions to everybody in the classroom and maybe not just to some of the people. We found that those follow-up questions, whether the answer is right or the answer is wrong, to help students understand the material are critical to their learning, and that everyone in the classroom should have that kind of interaction with the teacher. We have found that understanding how people attribute their success or their failure can make an impact on what they do the next time they have a test. So, and understanding the right way to praise people when they've done well, and the right way to help people understand what they do if they've not done so well on a test, how they can help that, how they can help them learn that it's persistence and hard work that gets them good grades, and not just some innate ability that they were given when they were born, because it's the hard work that grows the brain cells, and that's where the learning actually happens. And if you're not challenged by a test, then you really actually haven't learned a whole lot. And those kinds of messages presented to the students help all the students increase their knowledge, learn new skills, and are better able to actually compete when they get to college and persist in college to graduate. We also talk about neuroscience and how only a small percentage of who we are, or some percentage of who we are, might be genetically determined, but from a gender perspective, that males and females have the potential to perform equally well in math and science, and that also anyone of any race is capable of performing well in math and science, and that the teacher should expect the same high expectations from all their students, but developed a level of trust with the students, and that they would maybe not so much feel the stereotype threat that might accompany either their gender bias or their racial bias. So all these things are taught to the teachers, and they're allowed to go back to their classes and try different exercises. One thing we have them do is real world exercises on how to take a concept they've learned in science or math and make it applicable to a problem that they're seeing today that they would like to solve. And each time the teachers are trained, they're giving a new assignment to go back and try in their classroom. We look at the material, everything from posters to textbooks, to try to increase the number of minorities and females that are included and cited as contributors to new achievements in science and the math field, so that it doesn't look like it's just one gender or one race that's had all the contributions. So in the workshops that we give to the guidance counselors, we allow them to have a panel with a group of professionals in the area of technology or math, so that they can ask questions of those professionals, and they can learn from professionals what is more involved in those work days. One of the things that the Collaborative Fund has started at Texas Instruments is an opportunity for a speakers bureau. And a speakers bureau is available for professionals in STEM to go into the classrooms and talk to the students about their jobs. So in addition to the role models that we have in the physics camps, we also give professionals in the corporations an opportunity to go into the classroom. They talk about what's involved with their job, but they also talk about how they got to the place in their career that they are today, what they did from an education standpoint to get to their job. They talk about what they need to do to persevere when things in college or maybe even things in high school got hard for them, how they continued to work, what kind of rewards they get from being in technology or engineering, such that they can change the world, have an impact on society, make the world a better place to live. And all those messages are spoken to when they stand up in front of a classroom or go to a career fair at a school, so that a well-rounded picture of what engineering is presented, and technology is presented to the students when they speak to them. We have about 100 women and men that have signed up to speak to schools through our Speakers Bureau, and we match them up with requests from mostly 1st through 12th grade. We have teachers that contact us with a specific request, and we match that up with the right type of person. If they want a female, or if they want someone with a Hispanic background, a certain age range, we match those people up so that they can go to the schools and talk about their career and answer questions that the students might have. We also encourage them to do a little bit of a hands-on activity with the kids so that it's more engaging for them. We have done the physics camps and the teacher training both in Dallas School District and the Plano School District, but the teacher training has been able to expand to many other school districts. We've developed a curriculum for middle school as well as high school, and we've been able to go to community colleges where students might be getting their associate's degree and then go on as a technician into the areas of engineering and technology. And so our teacher training program has expanded beyond just high school to other areas of the pipeline. And we have reached over 400 teachers in the last 2 years through the programs through NAEP, and we've reached over 100 girls and through the physics camps over the last 2 years. But since the inception of the physics camps back in 2003, we are over 800 girls have been reached through the program. So the physics camp has had a wide breadth. Then the total number of teachers trained and counselors reached is close to 1,000 when we count all the programs together. So it's been pretty exciting to see the program start off as a pilot and grow to a much wider deployment through this. The Solid-State Circuits Society has helped by funding a short video that we are going to be including on the IEEE TV channel, which is a 5-minute little video clip that shows a little bit about how fun the camps can be, engaging and exciting, what types of material the girls learn when they're in the camp, and how those camps can be deployed to other places across the United States. We have are developing now and just now finalizing a replication kit for the camps, so that the teacher's guides and all the handouts, the lab work, the assignments, the answers to those, keys to those handouts and labs are all included in the teacher's guide, so that the camp can be taken to cities other than just Dallas. We also have video clips of all the wake-up activities as a way for teachers to learn how to, instructors that are going to teach the camp, what to do for the wake-up activities. So if there's any interest in having the physics camps or the teacher training come to your local city, I would love for you to get in touch with me and we can talk about how to get those programs deployed in areas other than just in Dallas. So if anyone has any questions at any time, feel free to ask me. In the meantime, I'm going to probably talk a little bit more about the physics camps. The physics camps start out with the first week, the girls learn about electricity and even actually the process of setting up an experiment and how to ask questions and what to do to look for results. We start off with light bulbs where they look at electricity, find out what causes the light bulb to come on. We talk about voltage, about current, about resistance, and they learn how to measure those with a voltmeter and a voltage supply. We teach them about circuits that are in series as well as circuits that are in parallel and how to compute resistances and of the total circuit. And we also integrate all of this effort with math skills along the way. We teach them about how to do the appropriate level math for solving some of the equations, as well as understanding how to compute the trajectories and the motion and the acceleration in the kinematics area. So the girls are exposed both to math and the physics part. The hands-on experiments are really good. They get to use electricity for the first time in the labs. In addition to that, we teach them a little bit about capacitors and how the light bulbs work and how to turn on and off LEDs. So they actually see the results of what they're doing in the lab. We break them up into groups of 3 so that they can collaborate and do labs together. And we have contests throughout the week to keep them engaged. We also bring in the speakers, and the speakers talk to them about how their job is relevant to what they're actually learning during the camp. And obviously we provide them with lunch throughout the day, and that's a great time for role models also to engage with the girls and learn more about what they're experiencing in school and answer questions about their career with the girls. The second week of the camp is related to kinematics, where they learn about things falling and being thrown up or at angles, and they learn about gravity, they learn about motion, and they have a great activity where they hold up a board and they walk in front of a motion sensor and detector that measures distance as well as time. They are shown a graph of motion versus time and distance, and they're asked to reproduce the graph by moving their body back and forward between the sensor and to see if they can match the graph. And they have a lot of fun with that activity. The second day in kinematics, they work on hitting the target. So they're given a specific assignment where they are told what angle a ball is going to be launched. They measure the launching velocity of the launcher, and then at a 0-degree angle, and then they try to compute when the angle is something other than 0 degrees, how far it's going to go and how high it's going to go. And by using the math skills that they've learned and the equations from the physics lecture, they're able to decide that if they stand 8 feet from the launcher, at what height the ball is likely to pass at that point distance from the launcher. And so they have a target that they've created, and they hold the target up the right height to see if the ball is going to hit at that point. And if it hits the target, they've they've completed the math assignment and the physics exercise correctly. If it doesn't hit the target, then they get to go back and work on it again and try it until they can figure out what the height of the ball is going to be when it crosses that point after it's been launched from the launcher. So that's a real hands-on exercise that they really enjoy doing. Another one is they have the ability to measure their pathway through kind of a maze, and they have a starting point and an ending point, and they have to compute the distance between the starting point and the ending point by going through the maze. Of course, the maze does not allow them to go directly from start to finish, but by doing addition and subtraction of all the east, west, north, south directions, they're able to figure out what the end point versus the start point vector looks like. It's another exercise they have a lot of fun with. They also are exposed to elements of optics, and they learn about refraction and reflection, and they learn about the way waves go, both sound waves and light waves, and all the hands-on activities we have them do for that. They talk about problems where gravity is involved with launching things, and try to predict the results of experiments before they happen, and try to understand where the equations come from and how they're derived. So a lot of this is very fun and hands-on and engaging. Another thing we teach during the camp is three-dimensional visualization. Visualization skills are something that with a little practice you can get a lot better at. So it's one of the things that we stress in the camp, because visualization is an important part of not only physics but a lot of the engineering things that they'll have later on. And so we teach them how to do some of those rotational things in their mind so that they can practice at it and get better at it. The last day of the camp, we actually have a contest where we have the girls broken up into teams of 3, and we give them a physics quiz. It's called a physics bowl, and they are allowed to compete against each other for prizes at the end of the game. So they have a lot of fun reviewing questions that have come up during the week about people, about subjects, about math, about physics. So it's a lot of fun for them, and at the end they all get prizes. The winners get to choose the prizes first, so some of the better prizes go early on, but everybody in the end of the day has gotten a prize from the physics contest, physics bowl. Another thing we do on the very last day of camp is we show them demonstrations with liquid nitrogen. And liquid nitrogen allows us things to get really, really cold, and when it comes to regular temperature, it changes from a liquid to a gas. And they see what that does and how the really cold temperatures change some of the things about physics that we know, and that not only is a change from cold to warmer, but it's also from a very small volume to a really big volume. And so those concepts are taught the last day, and we have lots of fun with even making ice cream when we work with liquid nitrogen, and that's the way we freeze the ingredients so that we can get ice cream at the end. And the girls like making ice cream and tasting it during the exercises. So those are some of the types of activities that we have during the physics camps. The programs that we've done started out as pilots early on, but have become programs that are now scalable to lots of places. The teacher training is called micro-messaging to reach and teach every student, and that training has not only happened in Texas, but it's happened in many places in Maryland and is being expanded to places in Ohio as well. So we're excited about the expansion of the teacher training. We are excited about being able to take the camps to other places besides Texas and share that with other people to show that we can have an impact on the ways that girls can learn in high school to better prepare them for a technical career when they get to college. The workshop we have for guidance counselors has really increased the amount of girls that actually sign up, not only for the regular physics, chemistry, and biology classes, but encourage them to go on to take those harder AP classes in physics and chemistry. So those have actually improved the enrollment rates, and the teacher training and the physics camps have shown to actually increase the number of girls that actually pass the AP exam, both in physics and chemistry, because of either the camps or the teacher training. So if there's any questions about these programs that you would like to know, or anything about the programs through IEEE or Women in Engineering, feel free to ask questions as the chat goes on. It's been somewhat of a one-way conversation so far, so if anyone has any questions, feel free to ask. We do have one question coming from the audience, and that was, what do I think the biggest challenge for engineers is in the future? Well, the National Engineering Society has come up with 20 great challenges of the next century. I think some of the challenges that we face in the future are how to get clean water affordable to everyone in the entire planet. It has to do with clean air. It has to do with and keeping our planet sustainable. Some of the challenges have to do with working on ways to monitor our health and detect early on when illnesses are at a higher potential or diseases have started, and ways to detect that really early so that treatment is much more highly probable to be successful. We have opportunities to connect the world globally through communication channels that didn't exist before. We have ways of building buildings that take lots less energy, and so that we can help our world use less energy to sustain where we are. We even have people working in the food industry as engineers to help us create crops that are more resistant to disease and higher nutrition values, so that we have a better chance of feeding the world population. So those are some of the challenges in the future that engineers might be facing, and having a diversity of people working on those challenges is one way to really have the world that we would like to see in the future. And we believe that people of all races, of all countries, of all genders, both genders, can be very instrumental in helping us solve those world problems. Let's see. I would also like to talk slightly about some of the early work that Texas Instruments did with when I first joined in Texas Instruments. We have a women's initiative network that helps us learn about what the workforce is doing, as well and how to succeed in our careers, as well as how we can help balance between the work and and our responsibilities at home, and how to balance those responsibilities and still be successful and engaged at work. We did have another question that came through from the audience, and this question was, when students participate in your program, how much knowledge do they typically have regarding STEM professions? Mainly it's through speakers and role models that come in. We've also worked with the speakers to talk about how their jobs impact the world and how they make the world a better place. So I think that, oh, it says STEM, yeah, professions. Yeah. Having those personal stories about how they've impacted the world through the jobs that they've had in the past really makes those professions come alive to the students that we have. We've actually been able to pilot an early tool that was developed that helps link professionals that are actually at their workplace with the girls in the camp and talk to them about how their job impacts the world and how what they're learning at camp changes, really is a stepping stone to what they're going to learn later on in college. And by doing that remote visit from professionals at the work site with the girls at the physics camps, we can tap into resources that might not otherwise be available to us. We could tap into a resource, and even in another city or across the country, across the world even. So we believe that a virtual visit from a role model can be as powerful as a physical visit in person. So that's one way we're trying to use technology to connect our role models to the girls in camp. See, another question that's come in is, how do you think society can help attract females to the STEM professions? Well, that's kind of how we can recruit and retain women in the fields. I think it's really important for colleges to make the classroom a friendly environment to girls as well as high schools. I think it's important for corporations to make their environment friendly to women when they come in, both early in their careers as well as later on in their careers. One element that helps is by either job sharing or telecommuting or even part-time work. When we first started with the Women's Initiative, it was slightly possible to have a part-time job at TI, but there were a lot of barriers to that, and we worked really hard at Texas Instruments to find ways to make a part-time work arrangement much more viable and work well for both the employee and the employee's manager, and make sure that the work was evaluated on clear metrics that were defined up front and not just the value of how much time they spent at work. It looks like there's one other question that might have come through from the audience. How did I choose my engineering field? That's an interesting question. My father was actually a petroleum engineer. So I grew up in a family where I had a parent that was an engineer, and he encouraged me to do anything that I wanted to. I was also interested in medicine because I wanted to help people. That was a real important part of my career aspirations. So I was lucky enough to have a degree in biomedical engineering, and that knowledge was used when I came to Texas Instruments. And the processors that we have developed and expanded work not only in helping people connect through communication channels, but also are used to create portable ultrasound machines. Some of the chips at TI are used to help find the veins in patients without being invasive, so that when they have to get IVs or shots, those kinds of images can be available to the doctors. We've created MRI, CAT scans, ultrasound machines. Those are the types of signal processing technology that's come to bear through being involved in a semiconductor company, but still impacting the world around us. So here's another question from the audience. What is the best advice that I have ever received in my career? And I think it's that you need to speak up and be confident. Oftentimes, being the only female in the room, it's real easy to kind of hide in the back of the room and just be a little bit of a fly on the wall. But actually, it's our role as engineers to be present and fully at the table and talking and bringing our ideas to bear. So having that ability to believe in yourself and have the confidence to speak up and be assertive is, I think, the best advice that I've got along the way. I've had many mentors in my career. I've had people that have been my advocate as well as my coach. People have lobbied for me to be nominated for TI Fellow and for IEEE Fellow, and have supported me along the way in every step of my career inside Texas Instruments and outside as well. And building those networks helps you get to information that you need, but also can be your advocates when it's ready. You're ready to take that next step in your career. So I have a funny story to tell about my nomination form for TI Fellow. One of my colleagues was on the committee that was reviewing the nomination forms for TI Fellow, and the committee read it and felt like maybe I hadn't met the criteria that was needed to go on to the next stage of voting. But my colleague took my nomination and rewrote it for me, unknown to myself. And he said he wrote it like a man would write a nomination form. And the next time the committee looked at it, they said, oh yeah, sure, she can do it. So that kind of taught me that being able to tout my own accomplishments in a more proactive, positive voice is better for you and your career, but also better for the people around you, and the projects that you're going to work on are much more valuable if you speak up and contribute than if you take a more passive role. So I wanted to thank mainly the sponsors for supporting me in this endeavor for the online chat. We have had support from the Solid-State Circuits Society, that is an amazing advocate of women in the profession, and I think we're really striving to increase the number of women involved in the Solid-State Circuits Society. I would also like to thank the National Alliance of Partnerships and Equity for helping to sponsor this. This is the nonprofit that helps deliver the 3 programs to those in the Dallas and Fort Worth area, with expansion to other cities across Texas and across the country. So I would like to thank both of them for their support financially and support in the programs that we've deployed so far to date. And of course, I'd like to also thank Texas Instruments for the opportunity to pilot these programs and collaborate with other women within the company and across the city. So I really appreciate all the support. I would also like to say that Women in Engineering is a great group, affinity group to have worked with in the Dallas area. And if there's a local chapter next to you, near you in your town, that you should get involved if you're not already involved in Women in Engineering. It's a great way to impact the people that are about to go to college, in college, and straight out of college. So thank you, Women in Engineering, for actually sponsoring the online chat. I appreciate everybody's participation today. And afterwards, there will be a video of this chat. And at the end of that video, there is going to be a short 5-minute video of the physics camp. Thank you for joining today.
Oh goodness.
We are going to have to give you a little sticker name tag. Quite match up or it's bent.
Womp, 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 womp. I like that. Trippy.
The one behind it's going to crash into it first.
The purpose of the physics camp is to take many young women who are taking more advanced science and math classes in high school, like Algebra 2 pre-AP, Pre-Calculus pre-AP, Physics pre-AP, and to give them a great experience that's going to build their confidence and give them exposure to some of this material in physics before they actually get in the physics classroom.
The part of camp that I liked the best was getting to talk to other women that are also in engineering and science fields and figure out, what they had to do to accomplish what they wanted.
I do think I would do better next year in physics because I had this experience. I learned like a lot in just 2 weeks.
I really enjoyed all the teachers' personalities were really awesome and really helped you be open to ask questions and stuff.
They're going to jump right in with their hands and grab on that equipment and be very comfortable using multimeters, very comfortable launching objects across the room.
We integrate math and physics and visualization techniques so that the girls get a well-rounded education while they're at camp.
The part of the camp that I like best so far is the demos because I'm a visual learner and I like to see how things happen and why they happen. And I like the explanations that are given after the demonstrations.
The most interesting thing was learning about nitrogen, frozen nitrogen air. That's the lab we just did.
So this banana is cold, very cold. You can see the condensation again in the air coming off.
It was interesting seeing how nitrogen can be taken from the air and frozen up. And then when it comes back into the atmosphere, it turns into a gas again, and how it changes volume because of pressure, which ties in with chemistry. So it was really interesting for me because I love chemistry.
Very comfortable not exactly knowing where this lab or experiment is going to go. But we're just going to try it and see what kind of data we get without fear of being wrong or fear of someone looking at you differently.
As a TA, I get to assist the teachers or the head people of the camp if they need me to set up a lab or help with papers or organize things.
I have more knowledge than what I came with, so it will definitely help me next year.
While the girls are at camp, we try to have them do a variety of activities. So in addition to hearing speakers on engineering fields and actually visiting engineering sites, we have them do math review because those math skills are things that they're going to need to use and apply to real-world situations. But we like to get them in the lab as much as possible. The girls need a chance to touch the materials, to use equipment, to maybe learn to use some equipment they've never seen before, so that when they go into physics next year, they're ready, they're confident, and they're not going to let other people take the equipment and relegate them to like note-taker status. We want the girls to be doing the science next year in their lab classes.
Being in camp definitely had a very good impact on when I took physics, and I went on to take pre-AP, AP Physics B and AP Physics C both, and it exposed me to physics earlier. It made me so much more excited about learning it.
We also have talks on specifically gender equity issues and bias that is in our culture and what the girls will be facing, and to expect some of those obstacles to come and how to best overcome them, the strategies that have worked for others.
We found that the girls that went to camp, 93% of them signed up to go on to college, as opposed to only 77% of the girls that didn't go to camp. We found that the girls that went to camp were more likely to actually complete college.
They're like, hey, this science, math, physics stuff, this is part of who I want to be. This is part of who I am. I'm getting better and better at it, and I feel like it's more something, not just that I'm doing, but something that's really part of what I want to do.
Say science! Say science!
I see you. I see you all. I have you in my power now.